Space heating systems. These types of active solar systems use liquids or gases as their media. They usually use mechanical instruments to store the heat and disseminate it everywhere. Fans, pumps, blowers, etc. are used to collect, store, and disseminate the heat where it is needed. Water heating systems. These types of heating systems are used to heat water at our houses, and after that they store and disseminate this heat to every place inside the houses. They are of two types: direct type and indirect type. In the direct type systems, in the collector, the water gets heated directly and disseminated through the pipes, whereas in the indirect type, the fluid gets heated in the collector and stored in the tank, and then, after the exchange of heat between the fluid and the water, it is disseminated everywhere. Pool heating systems. In these types of systems, there is no need for tanks to store water there. Water from the pool usually gets collected in the collector, then gets heated and again goes back to the pool. Thermal solar energy. This is one of the most important active solar energy examples. Radiation mode of heat is used to get solar thermal energy. Hot water that is used for domestic purposes can be obtained from this energy. Electricity can be produced from this energy in the power plants that are based on the solar concept. Domestic hot water systems. Domestic hot water systems are used to heat water and distribute or circulate this hot water using pumps. Some domestic hot water systems use thermosiphons for their activity, whereas others use pumps and other systems to work. In domestic hot water systems that work on the principle of a thermosiphon, the difference of densities of cold and hot water helps the water to circulate everywhere. This is another of the most important active solar energy examples. Photovoltaic panels. Initially, solar cells were made up of silicon, which is a semiconductor of heat and produces less electricity than a good conductor. So it gets doped with impurities so that it can be used to acquire solar energy directly from the sun and convert this energy to electric energy. In this way, solar cells are transformed into photovoltaic panels. In photovoltaic panels, when a photon reaches the doped silicon's surface, it transfers its energy to the free electrons that are available on the surface. After gaining energy, these electrons emit out, which in turn create holes on the surface of the semiconductor. When this semiconductor p-n junction gets exposed to the light, photons that carry more energy than the bandgap energy of C get absorbed, that in turn create electron-hole pairs. Electric fields affect these charge pairs, and their motion causes the flow of electric current. Solar thermal collectors. Solar thermal collectors are devices in which absorption of sunlight is the source of heat collection. These solar collectors can be used for decades without being damaged. So they are very advantageous and one of the most useful active solar energy examples. There are two types of thermal collectors. One is a concentrating collector and the other is a non-concentrating collector. Concentrating collector. In the concentrating collector, the area that receives radiation from the sun, aperture area, is much larger than the area that absorbs the radiation, absorption area. Here this aperture area acts as a mirror for the absorption area. Non-concentrating collector. In this type of a collector, the aperture area remains the same as the absorption area. A dark color painted conductor plate is an example of this type, where the area of absorption should be maximized to get maximum absorption of sunlight. Solar charge controllers. Solar charge controllers are basically voltage regulators. They usually regulate the energy that is flowing in photovoltaic panels and transfer the energy to the batteries. They regulate the energy flow so that overcharging of a battery charger cannot be done. There are two types of controllers. One is pulse width modulation controllers and the other is maximum power point tracker controllers. Pulse width modulation controllers. There is a direct connection between photovoltaic panels and batteries in these kinds of controllers. A rapid switch that is basically a transistor is used here for the modulation of charging of a battery. At first, the transistor remains opened until absorption voltage is reached within the battery. After that, it simultaneously opens and closes itself to regulate and maintain a constant voltage. In this kind of a controller, the output voltage of the photovoltaic panels is reduced to a great extent, which in turn decreases its efficiency. Maximum power point tracker controllers. In this kind of a controller, maximum power output can be achieved. Hence, it is far more advantageous than the previous one. It does not reduce the voltage of photovoltaic panels, so the efficiency of the panels remains the same. It is basically a DC to DC converter. This is one of the most important active solar energy examples. Solar panels usually get a constant amount of solar energy throughout the day. So these kinds of controllers track the solar panels and find the sweet spot where the best combination of voltage and current can be obtained for getting maximum output power. Decrease in usage of fossil fuels. Active solar energy is the best pocket-friendly source which can completely eliminate the usage of electricity, propanes, oils, etc. Decrease in pollution level. If the usage of greenhouse gases like methane, chlorofluorocarbons, etc. can be decreased and we start using active solar energy sources to generate electricity, we will be able to decrease the level of pollution at a global level. Please visit our website lambdageeks.com for more articles on technology, engineering, mathematics, and various other domains. Scientific calculator and many more other tools.